We rolling?
Yeah.
Welcome back, everybody. We're here to do beta decay equations now. Beta decay equation is when a beta particle is produced. Beta, sometimes written as 0 minus 1 beta. I'll explain about that a little more later. Or 0, negative 1 e. Because, let's not forget that what's happening here is the breakup of our happy little neutron family, where we start with a neutron which is actually secretly a proton and an electron cohabitating. And when the electron shoots out, for whatever reason, let's not judge, then we're just left with a proton. And so the point is that when you have a beta decay, you lose a neutron, but you gain a proton. So the number of protons goes up, the mass number goes nowhere. It stays the same because you go minus one of these and plus one of these. But anyway, let's do an example. Here's an example. Carbon-14. Carbon-14 is our happy radioactive isotope of carbon. Turns out, carbon-14 undergoes beta decay and spits out an electron. And just like this. And it's because one of its neutrons turns into a proton, spits out the electron. And that is interesting. Why? It's interesting because we have a lot of carbon inside of us. And every collection of any element always has a certain amount of each isotope. And so inside of our cells, a certain percentage of the carbon is carbon-14, and a certain percentage of that is decaying, which is interesting because inside of your cells you have a nuclear decay happening and a potentially hazardous beta particle flying out. In fact, Isaac Asimov estimated that at any given time in your body there are 30,000 beta decay reactions happening every second in your body. Always a surprising number. We have 100 trillion cells and we have a whole lot of carbon. So even with a tiny percentage of that being carbon-14, there are 30,000 beta decays happening per second in your body. But since we have 100 trillion cells, the chance of any, how did he put this? Any one cell would have to exist for 200 years to have a 100% chance of that happening in that cell. And so I guess that gives you about a 1 in 3 chance of that happening once in the lifetime of any cell, assuming that cell lived for 70 years, which they don't. So, anyway, to make a long story short, it could happen, but it's not that dangerous. Because also, nah, never mind. Let's move on. Okay, so we got carbon-14. Carbon-14 is going to spit out a beta particle. We will write that as 0 minus 1 beta. And the question is, what is left? Well, once again, what is left will be an isotope of some sort. And remember, since you lose a proton, or lose a neutron but gain a proton, this number isn't going to change. And that's why, if you do the math the same way, 14 minus 0 means that whatever isotope is left is going to have 14 as its total mass. And then, if you do 7 minus this one, negative 1, what is minus a negative when you're adding and subtracting numbers?
You put the parenthesis with the 2 negatives and it makes a plus.
Ooh, yeah, I never thought of it that way. But yes, subtracting putting the 2 negative sides together makes it a plus. And so really, it's 7 plus 1. But even aside from the mathematics, which might make your head spin, remember, you're gaining a proton. So it's just, that's really the thing to keep in mind. Without getting too caught up in the math, you start with 7 protons in carbon-14, and you end with 8 protons, which makes this what? Who's got their periodic table handy?
Oxygen.
I'm so sorry, but thank you for playing our game.
Oh.
Oh, you know why? Okay, here I am on record. I'm a bad teacher. Alright, so
suck at science.
Carbon's atomic number is not 7. It's 6. I suck at science. Let the record show. Mr. Auerbach sucks at science. And so that makes this not.
Or that.
How embarrassing. That makes this 7. Oh, goodness. I know. And that makes this nitrogen. Yes, thank you. Wow, I don't know how I'm going to edit that out to make it seem like all your fault.
You can have me cough.
I'll spend all night.
I have a nasty cough.
I'll put Seth's voice into the computer, saying it all wrong somehow. I'll superimpose another science teacher in my place, saying the wrong thing.
Or you could just make believe that the door opens.
The door opens.
Someone came in.
Someone came in. That's right.
Mr.
Anyway,
Whitey stopped by.
So that's a beta decay. Once again, that one was a little messy, and so I'm going to, do one more, and then I'll give you the worksheet, and we'll get on with our lives. I can't get the Godfather song out of my head. Yeah.
You have the Godfather song stuck in your head.
2 days now.
I had Happy Birthday stuck in my head yesterday.
Was it somebody's birthday?
Actually, I had Dancing Queen by ABBA stuck in my head this morning because Mr. Noren was singing it. Da, 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 da.
Do you know there's a heavy metal remix of that?
What's that?
There's a heavy metal remix of that.
Is it really? That I would like to hear.
I'll pull it up online if you want later.
Songs all the time and
It's like something that, it's their voices. The guy just went on and like imposed like all the other stuff to just like death metal it up.
Look up like Set Fire to the Rain Screamo. It is so funny.
Okay, let's move on with Beta Decay. Iodine 131 decays by Beta Decay. And that means that we're going to have a beta particle and something else. Okay, and so what's it going to be? Well, once again, don't forget, we lost a neutron but gained a proton, so our total mass stays the same, 131. We gain a proton here, or minus -1, and that means it goes to 54, which makes this xenon. Xenon, Xe. That is correct. And so, okay, folks, that's all. What I'm going to do right now is I'll give you a worksheet to work on, and we'll check in with each other before class is over and make sure we're all on the same page with this.